Hey everybody, Mr. Stewart here. Welcome back to part 2 of our lesson on permutations. This particular lesson will focus on purely skill building. So you noticed in the first part that there was some mention of factorial notation. So it would be good to sort of take a moment to review and also to extend our ability to work with it so that when we go back to probability-based questions, things will be quite a bit easier because we'll just have that facility in working with it. So notice the first expression here. Okay, so we have a fraction that contains 10 factorial in the numerator and 7 factorial in the denominator. So I'm going to reveal the first step to this, and then we'll reference that against the explanation. So what you can see here is the following, is that I have expanded the largest factorial we have, which is the 10 factorial. Okay, and a factorial is the product of the first so many, usually we say n natural numbers. So 10 multiplied by 9, by 8, and then by 7 factorial. Now I've chosen to stop at 7 factorial, okay, as it is the next largest one that we have in the expression. And the great thing about that, as far as simplifying is concerned, is that here I actually happen to have like factors. In this case, like factorials. So that means we can cancel them. Okay, so this is what it would look like following a cancellation. So we'd have 10 by 9 by 8. So recall to cancel, okay, I guess a fancy word for division or dividing out like factors. So for instance, by example, 7 factorial divided by itself, okay, is equal to 1. That is, anything divided by itself is equal to 1. That reduces to 1 over 1. So that's really what we mean when we say that we're canceling, is that we are reducing a particular fraction within the expression to 1 over 1. So that's why you may have seen in previous grades, when someone says, I'm just going to cancel these factors, they're taking the 7 factorial over 7 factorial and they're reducing it to 1 over 1. So that leaves us with a nice, tidy expression of 10 by 9 by 8, which is otherwise 720. Okay, so that expression has been evaluated. So again, the technique, expand the largest factorial out, that is to the next largest, and then look for like factors to cancel. So consider this one here. Okay, so we have 6 factorial divided by 4 factorial, and which is also multiplied by 2 factorial. So take a moment to think about your first moves. So as far as a first step is concerned, that largest factorial, the first largest, okay, is the 6 factorial. So we need to expand this out as far as this factorial here. Okay, so you can see that's been done through the numerator, and then 2 factorial is none other than 2 times 1. So that creates a great scenario because we now have like factorials in the top and the bottom of this fraction. So that means that those will cancel, right? Meaning that it reduces to 1 over 1. So simplifying 6 by 5 over 2 gives us a final value of 15. Okay, so there's a few examples of how to work with simplifying expressions that involve factorials. So last but not least, no lesson on simplifying expressions involving factorials would be complete without some form of equation. Okay, so once in a while we do have to work with algebraic expressions. So this one here is going to ask us to solve for n. Okay, in this notation here, you may have seen this before. This symbol here denotes belongs to. Okay, You might hear some tapping in the background. That's just the stylus on the tablet screen, so I apologize for that. And then W corresponds to the whole number system. Okay, so whole numbers. So we need to solve this equation for n, and n will take on the value of a whole number. Okay, so the same rules apply. We're going to expand out the largest factorial we have. Okay, and in this case, n factorial is larger than n minus 2 factorial. Okay, because n minus 2 is 2 less than n factorial. So we're going to take that numerator and we're going to expand that out. So it would be n multiplied by the next number, which is 1 less than n, multiplied by the next number, right, in succession, which is 2 less than n, and I'm going to leave that at a factorial. Okay, that's all over n minus 2. So the secret to solving these types of equations is to first deal with the factorials. Get it to a place where you can possibly cancel out like factorials. Okay? Because otherwise, we won't be able to solve the equation. We'll just have too many factors that have an n in it, and we do need to eliminate those factorials. So now we can cancel. Okay? So you've probably noticed here, let's see if I can't grab a hold of a different color. I've been exclusively using the same color all the way through. Let's go with green, see if that works. So n minus 2, yep, there we go. These are your like factorials. So those will nicely cancel out, leaving us with 1 over 1. Okay, and going back to the same color I had before, that brings us to the following. So we've canceled our like factors. So now we have n on 2, we're multiplied by a quantity called n minus 1, equal to 20. Okay, so this is going to take us back into grade 11, grade 10 mathematics, where we were solving equations that involves a single variable, but that we have 2 of them here. What we're going to have to do is to expand. Okay, so we're going to distribute. I'll leave this on a reduced screen format so I can easily toggle back between different color of pens. So we're going to expand. N by n is n squared, minus 1 by n is n equals 20. So what you may now see is something called a quadratic equation. Quadratic equations have 2 solutions, generally speaking, also called roots. Okay. So in order to solve that equation, what we'll need to do is to zero out one side. So if we subtract 20 from both sides of the equation, right, we'll end up with a 0 on the right-hand side. So in this step, we do need to set one side to 0. Okay. Following that, okay, you can either use a guess and check style of solution, but to factor a quadratic, provided that it's a simple quadratic or a simple trinomial, recall that we'll end up multiplying 2 factors together. Okay? And we're looking for 2 values. Those 2 values, okay, so the values we're looking for, that is the ones that will occupy these positions in our factors. We're looking for 2 values that will multiply to minus 20 and the same 2 values are going to add to negative 1. So those 2 values equal minus 1 when you add them. So that is going to have to be, for us, negative 5 and positive 4. So the product is negative 20, yet the sum of negative 5 and 4 is 1. So now we're close to a solution. When you solve a quadratic equation, right, you can eyeball this and we can see that n minus 5, that could be the factor that when multiplied by the other gives us that 0. Or the other factor, when you use it in multiplication, if you multiplied it by n minus 5, some value for n will give us that 0 also. So solving n equals 5 or n equals minus 4. Okay, so those two values will zero out the equation and thus are the solutions or the roots. Okay, so these are the solutions, otherwise known as the roots to the equation. But we do have to remember that the solution has a restriction. So n has to be a whole number. So that implies that n equals minus 4 is what we say inadmissible. So therefore, n would have to be equal to 5. Okay. So if we go back and we take a look and we check the solution, always a great idea. If we were to take that expression, okay, and we were to substitute in 5 as our value, and we were to simplify or evaluate, okay, that's 5 factorial over 3 factorial. It's going to get a bit messy here, so let me erase some of this material here. Make some room. There we go. Following the advice of expanding it out, that would be 5 by 4 by 3 factorial divided by 3 factorial. Canceling like factorials, we end up with a final result of 5 by 4, which is none other than 20. Okay, so within the practice that's been assigned, posted to the course website, under week 5, that is, you'll notice that there are some expressions that look like this, which will involve some similar skills.